Hi, I'm Will White, Solar Application Specialist at Fluke, and in today's DER Tech Talk, I'm going to discuss category and voltage ratings and why they're important when you're selecting a test tool for any kind of measurement, but really in the solar industry. The first thing we need to talk about is transient voltage spikes. These are a very short but high voltage spike, usually coming from the utility when we're working on a solar array. They can be caused by things like switching from the utility, lightning strikes. If you're working in a commercial or industrial building, sometimes load switching on and off can cause these transient voltage spikes. You can't usually see transient voltage spikes with standard test and measurement tools. We do have some power quality analyzers that can measure transient voltage spikes, but they're somewhat of a specialized tool. The important thing to know is that they're very short duration, they're a very high spike in voltage, and they come and go very quickly. The really important thing is that if a test technician happens to be doing voltage testing when a transient voltage spike comes, we want a test and measurement tool that's going to be able to withstand that transient voltage spike without damaging the tool, and especially not without causing injury to the test technician. Category ratings are related to the environment in which we're testing. There's category 1 through 4. The higher the number goes, the higher the potential for transient voltage spikes. There's an IEC standard that categorizes a solar array as a category 3 environment. We have to keep that in mind when we're selecting our test tools. Category 4 environment is the closest category towards the utility. That would be things like our meter enclosures, our main service disconnects, or if you're doing a utility scale solar inverter between the inverter output and our point of interconnection with the medium voltage transformer, would all be considered a category 4 environment where there's a higher hazard from transient voltage spikes. When we look at category rating, the category rating alone doesn't give us enough information. We have to look at voltage as well, which I'll talk about more in the next slide. It's important to have a tool that's going to have a category rating that's going to match the environment in which you're testing. So again, solar arrays are a category 3 environment, our point of interconnection, our lines to our medium voltage transformers are going to be category 4 environments. Now that we know the category rating, we want to talk about voltage. And solar is somewhat unique in that we test a large range of voltages. We could be testing 30 or 40 volts for a single module, up to 1,500 volts for a utility scale PV array. And that's just on the DC side. On the AC side, it could be 240 volts, 208, 480, even 600 or 800 volts on our utility scale systems. So we need to select a test tool that's going to have the category for the environment that we're working in and a voltage rating that's higher than the voltage that we will be testing at. Another important thing to keep in mind is that the category rating of the tool is not the only thing we have to think about. We also need to consider the category rating of our test leads. All Fluke tools come with matching test probes. So for example, our 393 clamp meter, which is 1,500 volt category 3 rated, comes with equally rated test probes. Now an issue arises where if those probes should be damaged, it may be tempting to go into the shop and just pull any test probes you have off the shelf, but there's a pretty good chance those probes are not going to have the same rating as the meter because that does have a high voltage and category rating. So make sure if you're replacing your test leads, you're replacing them with a set of test leads that matches the rating of your test instrument. Now voltage by itself can be misleading as well. If I have a category 3 1000 volt tool, that's rated for an 8000 volt transient. But if I have a category 2 1000 volt rated tool, that's only designed for a 6000 volt transient voltage spike. They're both 1000 volt rated tools, but because the category has changed, their ability to withstand transient voltage spikes has also changed. It's also interesting to note that some meters in the industry are designed to test to a certain voltage, say 1500 volts or even 2000 volts. But when you look at the category and voltage rating that the tool is designed and tested to, it's significantly less. So it might be 1000 volts category 3 or even 600 volts category 3. So it's important not just to look at what the tool is capable of measuring, but what it's designed and tested to as well. Now with Fluke tools, it's really easy to figure out what the category and voltage rating is. It's printed right on the outside of the tool. Here we can see a Fluke multimeter. This is a category 3 1000 volt, category 4 600 volt rated tool. Also, we have our line of clamp meters. On the left-hand side here, you have the 325 clamp meter, which is category 3 600 volt rated. In the middle, we have the 378 clamp meter, which is category 3 1000 volt rated. And on the right, we have the 393 clamp meter, which is category 3 1500 volt rated. Now these photos are relatively to scale, so you can see as the voltage rating goes up, the size of the test tool goes up as well. And that's because there's additional clearance inside that tool to provide additional layers of safety in case there's a transient voltage spike. So just to recap, it's important to know what environment you're working in and what category that's going to be, and then select a voltage rating that's above the voltage at which you will be testing. It's important to have the proper tool to stay safe in case there's a transient voltage spike. For more information, visit fluke.com. Thank you.